Hello to you all. Welcome to another session here with us at Mathematics Resource Center. And today we'll be looking at the topic volume, and we'll also be looking at some amount of capacity and mass and density as well. So we'll be doing this question. It is January 2019, paper 2, and let's just go with the question. Alright, so the question says the diagram below, not drawn to scale, shows an open cylindrical container made of metal with a circular base and uniform thickness throughout. The length of the container from the top to the bottom is 120 centimeters, right? And the inner and outer radii are 14 centimeters and 15 centimeters respectively. Take pi to be 22 over 7. So far, they have given us a bit of information. So they mentioned two radii. So one is 14 centimeter and the other is 15 centimeter. They mentioned that there is a uniform thickness throughout. That means right around the container, from the side coming right down to the bottom, there's a uniform thickness, and they highlighted it. So that's something, another important thing that we need to remember. And it has a circular base, right? So they mentioned that it was a circular base, and when you look at it, you realize that it's a cylinder. So definitely it has a circular base, right? And the next part is so they give us the height, which is 120. So the first question says, draw a cross-section view of the container showing the measurement of the inner and outer radii. So when we look at it, the inner radii, say this is the center, coming here, the inner radii, because they say the inner is 14 centimeters, right? And then the outer going there, from there going straight out, we should stop right here, right? So from there going straight out, so that would be 15 centimeters, right? So whichever way you write it. So they ask us to draw a cross section showing that. So we're going to come down and we're going to draw two circles. You would be expected to use your compass to draw your circle, draw a proper circle, and then you would have your center, and then inside of that you just go again and draw a second circle. All right, so maybe what you could do is measure these 14 centimeter, draw a circle of 14, and then draw a circle, another circle 15 centimeters. All right, so it is, they say draw a cross section. You don't necessarily have to draw it to scale, but you're going to put in your measurement, but you need it to be proper circle, right? And then from here to here, you're going to put in, so we can go here, it would be our 14 centimeters, and then from the center going straight out, that would be our 15 centimeters. Oops, let's get that part proper. All right, so here would be our 15 centimeters. All right, so this is what your cross section would look like. Not drawn accurately because I'm just freehand drawing this, so you need your your compass to draw this properly. All right, and you put in your units. Good. So now we have our cross section. Let's see what the next question says. And this is 2 marks. 2 solid marks, easy marks. All right. So let's go to the next one now. And it says, show that the capacity of the container is 73,304 centimeter cube or cubic centimeters. All right. So we're going to show that the capacity is that. And when we talk about capacity, the capacity of a solid is how much it can hold. And when you look at this solid, I think of one of those teacup that it have a certain amount of thickness so that it can keep your liquid or your food warm, right? So I'm thinking of that when I look at this cylinder, and it occupies more space than what it can actually hold because they had to do some padding, right? In order for it to be able to trap the heat and hold it, keep it hot for a while. So they have extra padding. So it occupies more space than what it actually holds. So the the capacity will be in this small circle here. Yes, so this what space is here? What amount of things can I pack in this small space right here? Not the entire thing, but that space. So when we look at that space, we know that the radius for that would have been 14 centimeters, right? And let's look at the height now. Remember that they said it's a uniform thickness throughout, right? So if from this part to this part is 1 centimeter thick, then that means from the bottom coming up is also 1 centimeter thick, right? And how we got that 1 centimeter? If from the center, if the small circle inside is 14 centimeter and then to the larger circle it's 15 centimeter for the radius, then that means the thickness throughout will be 1 centimeter, right? So we know that down here the thickness is also 1 centimeter, which means that the height for the inner circle or the inner cylinder would not be 120 centimeters but actually 119 centimeters, right? Now that we have established all of this, let's go down to our question and write in your solution. So they ask us to show that the capacity of the container is 73,304 centimeter cube or cubic centimeters. So let's go with the volume now. Still volume we're working out, but it's the volume of what it will actually hold. So it is pi r squared times height. So it's the area of the cross section times the height. So we're going to go, and for pi r square, we're using pi as 22/7. That's what they said. Times, and remember now, the radius of the small circle is 14 and the height we're using is 119. So the radius is 14. So that would be 14 square, or we could write 14 times 14, and the height is 119. Good. So now we go ahead and we simplify. So we're going to go and say 7 to 7, 1, 7 to 14, 2. Now we're going to go ahead and work this out. So we have 22 times 2 times 14 times 119. And that gives us 73,304 cubic centimeters. And I could write hence proven. Alright, so we have proved that the capacity is 73,304 cubic centimeters. Well done. Alright, so that's 2 more marks. Let's get to the next part of the question now. So the next part of the question, value 3 marks, it says, determine the volume of the material used to make the container. So we're now going to determine the volume of the material used to make the container. And for this, what we're going to do now is that we're trying to find out how thick that material was, right? And in doing that, to find out that volume, that space that that material occupies, because we realize that all of the space wasn't used for what it can hold. Some was just used to keep at it, so it can to keep it for the to build the cup then, right? So we're interested in finding the thickness of the material. How much what amount of material that space that keeps up, right? So we're going to go ahead and find the volume of the wider circle. We know the volume of the smaller circle already, so we're going to find the volume of the wider circle and then do a subtraction, and that will leave us with this part, the thickness. Let me see if I use another color. So it will leave us with this part. See this part going around? That thickness of it? The thickness of it? Right. So we're trying to find the volume of that. So alright, scroll down to a question. Good. So go ahead now, and we're finding the volume of the circle with the radius 15 centimeters. right? So the cylinder with the radius 15 centimeters. So it's pi r square h. So volume equal pi, which is 22 over 7 times 15 square, which is 15 times 15 times 8. And this time h, we're looking at the bigger circle, right? So it's going to be the entire length from there coming up. So we're using 120 centimeters. All right. So we come down and it is 120 centimeters. So we'll go ahead and we calculate this using your calculator. 22 times 15 times 15 times 120 divided by 7. And that gives me 84,857.14. And I'm keeping it at 2 dp for now, and then we can round it off to one decimal place after. Alright? Or to a whole number. The question didn't specify. So this is for the large circle, for the large cylinder. So now we're going to find the materials used to make the container itself. We're going to subtract. So we're going to subtract the space, the small one, the volume of the small one from the volume of the large one. And the volume here for the small one was 73,304. So we go ahead and we say volume of material. So the volume of the material is 84,857.14 subtract 73304.00. No, just write it like this. So that's 4, that's 1, that's point, and that's 3, 0 from 5, 5, and that's 5 again, and that's 1, and then that's 1. So this is now 11,553.14. Alright, so the volume of the material would be 11,553.14 cubic centimeters, and this would be the volume. Alright, so that is the volume. Good. So we're finished with that question. So it asks us for the volume of the material used to make the container, and we have found the volume by finding the larger one first, subtracting the smaller one from the larger one, and what's left would be the volume of the material. Alright, so we'll come down to the final question. And the final question now says, given that the density of the material used to make the container is 2.2 gram per cubic centimeters, determine the mass in kg of the empty container. So we're determining the mass of the empty container, and they gave us a formula, right? And they say density equal mass divided by volume. So what we're going to do is to just transpose this formula to figure out what volume would be. And in transposing this formula, I multiply both sides by volume. Multiply both sides by volume. Right? So when I multiply both sides by volume, the volume here cancels the volume there. So therefore, mass is equal to volume times density. Alright? So I transpose, I rewrite it. I want to find mass, so I rewrite the formula that they have given me, and I can use that to find the mass. Alright, so they say given the density of the material used to make the container is 2.2 gram per cubic centimeter, determine the mass in kg. Alright, so we're going to go ahead and we're rewriting this now. So we have mass equal volume times density. So the volume of the material, as we have up here, is 11,553.14 So 11,553.14. So I'm keeping my decimal until my final. So keeping my 2dp. Alright, times the density, which is 2.2 gram. Alright, so I write that down and working that out, 11,553.14 times 2.2, and that gives me 25,416.9. So I leave it at one decimal point now, grams. Alright, and the question asks for me to give my answer in kg and not gram. So if I have 25,416.9 grams, then I'm just going to rewrite that in kilograms. And to rewrite that in kilograms, I need to remember my conversion. So how much gram make a kilogram, right? So I need to remember that conversion. And I know that 1,000 grams equal 1 kg. So I'm going to go ahead and gonna divide this by 1,000, right? So dividing by 1,000, move my decimal place 1, 2, 3, 4 places. So my answer is now 2.5469 kg. Alright, and now we could round it off to one decimal place, which would put us at 2.5 kg. Alright, the question didn't specify, so I would round it off to one decimal point. Alright, and that would be it for the last question, finding the mass of the material. So the mass of the material would be 2.5 kg. Alright, and the total marks for this question is 9 marks. So here we start with 2 marks, then we got another 2, so that's 4, plus another 3, so that's 7, plus another 2, and that's 9. And this is a really good 9 marks that you can get on the exam. It is January 2019 paper 2, right, CSEC. So watch the video, watch it again, practice the skills. Things that you must know for this is you must know the area of to find the area of a circle. You must know the cross section of a cylinder, so you must know what the uniform cross section of a cylinder is and be able to draw that. You must also know how to transpose, so you're rewriting the formula for finding density that they have given you, so you can find the mass from that. So you must be able to transpose. You must know the conversion between grams and kg, right? So how much gram make a kg, therefore you'll be able to divide to rewrite that, right? So those are some of the skills that you need for a question like this, right? So practice, can't say it enough. Practice, you just need to do a lot of practice. Go over this, watch it, get your question, the 2019 paper, try doing it on your own and practice those skills. All right, so that's it for our video. Do join us again for another video on volume, surface area again. So we'll be doing another video coming out shortly. And remember to like, subscribe, and share so that other persons can benefit from this content and will definitely know how to work out these questions when they actually go into the exam. Until then, have a good day. Bye bye.